DB 2020, paper 1, question 4. They want me to differentiate from first principles. First thing I'm going to do is write down my formula from first principles. So f of x plus h minus f of x all over h, and you get the limit as h tends to 0. So hopefully you understand where this formula comes out of, in order to make it easier to remember. But you know, it's actually, this part here is based on your junior cert stuff, and this is the only kind of new part to do with the fact that we want instantaneous rate of change, not average rate of change as you were doing in junior cert. So I'm just going to fill this in. We need f of x, I have it. We need f of x plus h. So if that's f of x, then f of x plus h, anywhere I have an x, I need to replace it with an x plus h. And you're going to clean that up. Continue to clean that up. You know, I'm literally just doing this part first, just getting that as cleanly and as simply as possible. Minus 4xh minus 2h squared. And probably can't really clean that up too much further. So there's your f of x plus h minus your f of x. So that minus is going to impact everything after it. And again, I'm literally just going to clean that up. Okay, and I'm left with the minus 3h minus 4xh minus 2h squared. So I've done f of x plus h minus the f of x. I need to divide by h. That gives me a minus 3 minus 4x minus 2h. And I'm going to get the limit as h tends to 0. So as this would get smaller and smaller and smaller, I end up at minus 3 minus 4x. So they want me to differentiate it from first principles. There it is. How do I know I'm right? Well, just differentiate this without first principles. So you bring the power in front, you subtract 1 from the original power, bring the power in front, subtract 1 from the original power. I know I'm walking out of the exam with full marks. Part B, the equation of a curve. So we know it's a cubic. We don't really know if it starts low and ends high or starts high and ends low, etc. But it said the coordinates of a turning point are 0, 2. So what do we know about a turning point? Straight away, f dash of x is equal to 0. And the coordinates of a point of inflection are this. What do we know about a point of inflection? F double dash of x. So your second differentiation is equal to 0. It looks like as well. So turning point, well, the point 0, 2 is on the curve. It's a turning point. Now I don't know if it's this one or this one, but anyway. And the point of inflection is also on the curve. So that's 4 pieces of information that I have there. I have this point is on the curve. I'm going to sub it in. This point, it's your point of inflection, is also on the curve. I'm going to sub it in because I don't really know what else to do in order to find this out. So if I know a point's on a line, I'm going to sub it in, and that point is on that line, I'm going to sub it in. Here, I'm going to do a differentiation and let it equal to 0. And here I'm going to do a second differentiation and let it equal to 0 because they've given me that information to do with those as well. So that's kind of everything that I can think of at the minute to do with what's written here in front of it, and we'll just see where this goes. So I'm going to sub that in. So subbing it in, x is 0, y is 2. So that's 2 is equal to a times 0 cubed plus b times 0 squared plus c times 0 plus d. Oh, actually, you can see very clearly there, d is 2. So I'm going to have to figure something out very fast. So we now know that d is 2. I'll actually just write it down here. down at the very bottom here where they've given me the space. What else can I do? I've said this point is on the curve. I'm going to sub that in. So x is 1 and y is minus 1. So that's minus 1 is equal to a times 1 cubed plus b times 1 squared plus c times 1 plus d, which I just have found out is 2. So, sorry, plus c times 1. So now I have minus 1 is equal to a plus b plus c plus 2. Bring that over. A plus b plus c is equal to minus 3. Just trying to save myself a little bit of space there. Looks like a simultaneous equation. 3 equations, 3 things missing. I only have 1 there. So let's just see. There's my first one. I don't know. What else do I know? So I know that when x is 0, you know, the turning point is 0, 2. So when x is 0, for my differentiation, so what is the differentiation of this? F dash of x is equal to 3ax squared plus 2bx plus c. And I know that that's equal to 0 when the x coordinate is a 0. And that looks like c is equal to 0. Okay, so I'm not going for 3 simultaneous equations, 3 things missing. So I hope you understand that the slope is 0 at a turning point. And the question tells me that it's at this point here when x is equal to 0 that the slope is 0. F dash of x. So I need to differentiate this. So that's 6ax plus 2b. And what do I know about this? I know that that is equal to 0. So because I have a point of inflection, so f dash of double dash of x equal to 0. When x is a 1, now I can actually go to here now and just even see a 0. So actually I'm looking at a junior cert simultaneous equation. I'm going to multiply this by a minus and this by a 2. So if I take this one, multiplying it by 2, that's minus 6 is equal to 2a plus 2b. And I'm multiplying this by a minus. That is 0 is equal to minus 6a minus 2b. And that's minus 6 is equal to minus 4, which means minus 6 minus 4a. So I'm going to change those to pluses. And a is equal to 3 over 2. Which means if a is equal to 3 over 2, what's b? C is 0, sorry, from up there. And I'll just go back to maybe a straightforward one. A plus b is equal to minus 3. So a, we've said, is 3 over 2. Plus b is equal to minus 3. Bring that over. B is equal to minus 4.5. So, I don't need to write this out like this, but I just want you to know the function would be y is equal to 3 over 2x cubed minus 4.5. Now, if you want to keep it in all fractions or all decimals, that's fine. X squared plus 0x plus 2. So that's actually what the function looks like when I found out a, b, c, and d. And just be sure a is an integer, yeah, that's fine. B is an integer, C is an integer, and D is an integer. Yeah, I've given it the way they wanted. And the very last part, hence find the coordinates of the other turning points of the curve. All right, so turning points is f dash of x is equal to 0. So that's 3 times ax squared plus bx plus c. No, sorry, plus 2bx plus c. What am I doing there? I now know a, b, and c. So that's 3 times 3 over 2 x squared plus 2 times a minus 4.5 x, and c is 0. So that's 9 over 2 x squared minus 9x. So that's f dash of x. What are we looking for? We're looking for turning points. So f dash of x is equal to 0. And I'm going to take the x out in common. And I have found that x is equal to 0 is one option. And 9 over 2x minus 9. I'll multiply across by 2. X is equal to 2. Let me just check that now, because I was given a turning point. Oh, no. So something has gone wrong in my maths there. So that is 4.5x squared. Oh no, yeah. Yeah, sorry. Yeah, this is the one we were given. The turning point that we were given. So that would be that one. If I continued on there, I'd find out that y is 2. That's what it looks like. And then over here is my other one. So when x is 2, you can sub it back into y, and you would find out that y is minus 4. So 2 minus 4 is the other turning point. If you're happy with all that and you don't have any questions, feel like you understand it, then these are the questions I would probably do. All slight twists on what we've done there. Some of them more twists than others, like some of them aren't differentiation, some of them are integration, but it doesn't matter. They're similar. They're all similar. Some are section B and some are section A questions.